Welcome to A-Level and AP Physics. In today's lesson, we will discuss some important past paper questions on electricity and radioactivity from March 2021, paper 1-2. For question number 36, it is given to us a cell that has internal resistance is connected to a switch S and a variable resistor. A voltmeter is connected between the terminals of the cell as shown in this figure. Means voltmeter is connected across terminals of the battery, and this is voltmeter. It is given to us when switch is open, voltmeter reads 1.50 volt. The switch is then closed and variable resistor is adjusted to have a resistance of 4 ohms. The voltmeter now reads 0.75 volts. Question is asking us to calculate what is the internal resistance of the cell. For this question, it is given to us when the switch is open, voltmeter reading is equal to 1.5 volts. It simply means that there is no current in the circuit. As there is no current in the circuit, the voltmeter reading will be equal to EMF of power supply because there will be no energy loss in the power supply. So simply we can say EMF is equal to 1.5 volts. It is also given to us when the switch is closed, mean when we close the switch, resistance of this resistor is equal to 4.0 ohms. It is also given to us the voltmeter reading now is equal to 0.75 volts. Simply we can connect another voltmeter here. Let's say we connect another voltmeter across this variable resistor. Reading on this voltmeter also will be equal to 0.75 volts. Now we have EMF of power supply. We can write down EMF will be equal to VT, means the terminal potential difference plus the V lost in the battery. So this is V lost. EMF is equal to 1.5 volts and terminal potential difference is equal to 0.75 volts. Now from here we can find out value of V lost. V lost from here will be equal to 0.75 volts as well. Now if you look at the value of terminal potential difference, means the potential difference across this resistor or across the terminals of power supply, that is also equal to 0.75 volts. As these two potential difference, they are the same, and current passing through the internal resistance, means internal resistance is here and this is our external resistor. As current passing through each of them is the same, so we can simply write down IR. This will be equal to I times capital R. As current is the same, so it simply means that small r, this is equal to capital R, because V lost, this is equal to VT, means the terminal potential difference. So from here simply we can find out internal resistance, this will be equal to 4 ohms because capital R is equal to 4 ohms. So this is one way we can calculate internal resistance. But another way to calculate internal resistance is, first of all, we can calculate value of I. If you look at this external resistor, we have potential difference across this external resistor. Simply we need to divide by its resistance, and the resistance of external resistor is 4. So simply we divide 0.75 by 4 and value of current will be 0.187 amps. So this is current in the circuit when the switch is closed. So simply we can write down this is value of I. Now we need to find out internal resistance. Internal resistance V lost is equal to I times small r. We need to find out internal resistance, so V lost is equal to 0.75. We need to divide by I, that is 0.187. So our answer will be 4 ohm. This is another way you can find internal resistance. So answer for this question is C. For question number 37, it is given to us a cell of electromotive force capital E and negligible internal resistance is connected into a circuit as shown in this figure. The voltmeter has very high resistance and reads a potential difference V out. Voltmeter has very high resistance. It simply means that this is an ideal voltmeter and no current will pass through this voltmeter are negligible. Simply we can ignore that. We need to find out the ratio between V out and E. We can answer this question using different methods. Let me explain to you using the simplest method to answer this problem. For that purpose, we need to redraw this circuit so you can see the clear picture of this circuit. So as you can see, the cell is given and there is one resistor that is connected across this cell. So this is that resistor, and EMF of the cell is given is capital E. Resistance of this resistor is given, that is 12 ohms. Next we have two resistors, and these two resistors, they are connected in series. So this is one resistor and another resistor that is connected in series. So simply we can redraw circuit like this. So simply we can connect voltmeter here. This is connected across 4 ohm resistor, and the reading on this one is V out. This resistor has resistance of 2 ohms and this is resistor of 4 ohm. Now simply we need to find out the ratio between V out and E. In order to find the ratio between V out and E, we can simply connect another voltmeter across these 2 points. Across these 2 points is the same. If I connect across these 2 points another voltmeter, let's say this is an other voltmeter, the reading on this voltmeter will be equal to EMF, because this point is connected with positive terminal and this one is connected with negative. So the reading on this one will be capital E. So this is capital E. From here we can say that the ratio between E over total resistance in this branch, that is 2 plus 4, has to be equal to the V out, means the reading on this voltmeter divided by this resistance by 4. Now we need to find out V out. Simply we can write down V out by E. This will be equal to 4 divided by 2 plus 4. Now if we simplify, our answer will be 2 by 3. So that's the answer. So the answer for this question is 2 by 3, and this is the answer. So this is the simplest way you can find out. Question number 38 is a typical type of question on potentiometer. For this question, it is given to us a battery is connected to a potentiometer. The potentiometer consists of a uniform resistance wire and a sliding contact P. This is uniform resistance wire. It is connected between Q and R, and P is sliding contact. We need to find out which graph shows the variation with distance d of the potential difference V, means the reading on this voltmeter. First of all, let's try to find the potential difference between point P and point Q. So we can simply write down VPQ, and VPQ will be equal to current passing through this wire times the resistance between point P and Q. So we can say RPQ. We also need to understand, as this voltmeter is ideal voltmeter, it simply means that its resistance is infinite. If the resistance of this voltmeter is infinite, it means there will be no current passing through this rod. So this is a very important point. We need to be very clear. It also means that if current I is coming from this power supply, current I will also pass through this wire, but no current will pass through this voltmeter. Now if you have this understanding, now simply we can write down I times the resistance of the wire, we can say is the resistivity of the wire, times we can say the length of the wire, so we can say rho times LPQ, divided by cross-sectional area of the wire. Now in this case, I is the same, so current passing through QP and current passing through PR is the same. So we can take I out, and wire is the same wire, because this is the same wire between point Q and P and also between point P and R. So rho is also constant, because the same wire, it is made of the same material. It means resistivity is the same. Wire is the same, so it means cross-sectional area is also the same. Now simply we left with L, in this case LPQ. So this is LPQ, this is equal to D. So we can also write down here. So we can replace LPQ with D. So this is D. Now if these quantities, they are constant, we can simply say that VPQ will be proportional to D. We can also say that VPQ means we can write down VPQ is equal to some constant times D, and constant in this case I is constant, E is constant means the rho is constant, and cross sectional area of the wire is also constant. So these quantities are constant. Now from here we can simply sketch a graph between two quantities, and these two quantities, they are directly proportional. If two quantities are directly proportional, the graph has to pass through origin and it has to be a straight line. So this is simply telling us y is directly proportional to x. So the answer for this question is A, because V is proportional to D. So the best answer is A for this question. For question number 39, it is given to us an unstable nuclide X decays by emitting an alpha particle. Which nuclide is formed by the decay of nuclide X? For this question, it is given to us an unstable nuclide X decays by emitting an alpha particle. First of all, let's try to understand what is alpha decay. If we have better understanding of alpha decay, we can answer this question very easily. Alpha decay is simply, let's say we have nucleus X and the atomic number of this nucleus is Z and the mass number is A. This decays to another nucleus Y by emitting alpha particle, or by alpha decay. Alpha particle has atomic number 2 and the mass number 4, means it has 2 protons and 2 neutrons. So the atomic number of this new nucleus will be Z minus 2, means the proton number will decrease by 2. Atomic number is equal to proton number, and the mass number of this one will decrease by 4. Or we can simply say that in alpha decay, proton number decreases by 2. So we can write down proton number decreases by 2. You can say minus 2. And a neutron number also decreases by 2. So we can write down neutron number also decreases by 2. So we can write down negative 2. Now simply we need to look at this nucleus X. Its proton number decreases by 2. So it has proton number 94. Now it becomes 92. So simply we can draw this line here. So proton number decreases by 2. And neutron number also decreases by 2. So if we go down, this is telling us neutron number decreases. And this decreases by 2. So this is our new nucleus. This is new nucleus. So the answer is B for this question. For question number 40, we need to find out which nucleus contains equal numbers of up and down quark, means up and down quarks. We can look at each nucleus and then we can find out which nucleus has the same number of up quark and same number of down quark. I will simply go to helium first of all. If you look at helium, it has atomic number 2 and the mass number is 4. This is telling us it has 2 protons. So simply we can write down it has 2 proton. Atomic number is 2 and atomic number is the same as proton number. And its mass number is 4, and the mass number is equal to number of protons plus number of neutrons. So the neutron, we can say the number of neutrons in helium nucleus, they are equal to 2 as well. Next thing we need to understand, proton, this consists of 2 up quark and it consists of 1 down quark, but we have 2 protons, so we need to multiply by 2. Neutron consists of 1 up quark and 2 down quark, and there are 2 neutrons in the nucleus, so we need to multiply with 2. From here we can write down the number of up quark, 2 times 2, so we have 4 up quarks in 2 protons and we have 2 down quarks, so we have 2 down quark here. Now if you look at neutron, neutron has 1 up quark, and if we multiply with 2, so it has 2 up quark, and it has 2 down quark and we multiply with 2, so it has 4 down quark. Now if we look at the number of up and down quarks, so these here we have number of up quarks, so the number of up quarks we have total 6, and if we look at number of down quarks, we also have 6. So helium nucleus has the same number of protons and same number of neutrons, also the same number of up quarks and same number of down quarks. So the answer is B, but you can check remaining nuclei by yourself one by one. You will see that up quark will not be equal to down quark, means the number of up quarks will not be equal to number of down quarks for the remaining nuclei. They will not be equal. So only in this case, helium nucleus have the same number of protons, same number of neutrons, and also same number of up quarks and same number of down quarks.